Hey there, it's Mr. Barbera. Hope you guys are having a good day. Without me there, or Mr. Goldman there, if you're in Mr. Goldman's class watching this right now. So I'm gonna give you just this little video here to review, or not to review, but to build on what we did yesterday. So yesterday in class, we saw a pattern for repeating decimals. We saw that fractions of the form 73 over 99. Anytime you're over 9 or 99 or 999, we always had a repeating decimal. So we saw yesterday that 73 over 99 would be 0.73 repeater. And that's fine because we saw the pattern, but we want to prove it to ourselves. So I'm going to go through this proof with you. And what I want you to do is, as you're watching the video, write with me in your notebooks. You might want to pause the video for a second, make sure you have everything ready. So what we're going to start with first is we're going to say that we have the number 0.73 repeater, and we're going to set it equal to x, meaning that it is just x is some number. We're just going to define it as 0.73 repeater. And we know that 0.73 repeater is repeating decimal, so we could write it as 0.737373, and I'm just going to do ... just to symbolize that it would go on forever. And that's still equal to x. Now what I'm going to do is I want to get rid of the repeating decimal. So the way that I can get rid of a repeating decimal, since it goes on forever, is to subtract that same repeating decimal. But we're going to do a little trick here so that we have something left over afterwards. So what I'm going to do is, as long as I do the same thing on both sides, my equation stays balanced. So I'm going to multiply both sides of this equation by 100. And the reason I'm doing that is multiplying by 100 here in the repeating decimal is going to move the decimal over twice, just like we do in a percentage. And if I come down a line, I now know that 100x equals 73.73 repeater. Because again, just like we've learned with percentages, the repeating decimal doesn't stop repeating just because we move the decimal over a little bit. Okay, now we want to get rid of this repeating decimal. Well, 0.73 repeater we know is equal to x because we said so up here. So we're going to go ahead and we're going to subtract 0.73 repeater from both sides. But on this side, we're going to call it x. Remember, these are equivalent. I'm taking away the same thing on both sides. But what I'm doing is now these are going to cancel out. 0.73 repeater and 0.73 repeater cancel out. And I just have 73 on that side. On the left, if I have 100 x's and I take away one of them, I have 99 x's. You might have noticed at this point that these two numbers are the two numbers that we're going to need to get to our fraction of 73 over 99. My final step here, since it's 99x equals 73, I can just divide 99 on both sides. This is a giant 1 over here. And I now know that x equals 73 over 99. And that is how we can prove that 0.73 repeater is equal to 73 over 99.